Hey guys, so this is homework 10.1. This is the beginning of the statistics unit. This video is mainly just going to be on some different vocabulary words that you need to know. It's not heavy on a lot of math, this particular lesson. Okay, so let's start off with just talking about two words, data and variability. Data is something you've heard before. Data is in our newspapers, science classes, economics, medicine. Variability is the property of outcomes being different. So we're going to talk about a few different types of variability. So the first type of variability that you see in exercise 1A is observational or measurement variability. And this variability is introduced due to either our measuring instruments not being precise enough or differences in how two different people read the measurement. So kind of like think about when you take a ruler, if you were to take a ruler and measure something, and really being as precise as possible. Maybe I measure something and I get 2.3 inches, but maybe Miss B's measures it and she gets 2.35 inches. So that's an example of variability in measurements. So what you're asked to write in the space provided is an example. So here's my example. Two students independently measure the amount of time it takes for a ball to fall a given distance. Because the students have different reaction rates in starting and stopping the timer, there's a variability introduced into the data. So I don't want you to write this example down. I want you to write your own example down. So don't copy this example. Okay, let's look at part B, another example of, or another type of variability. This is called natural variability or inter-individual variability. This variability that accounts for the fact that members of a population are simply different. So here's my example. Remember, you're not writing my example down, you're making your own example up. So if two people work out the same amount of time at a gym and yet lose different amounts of weight, two plants are given exactly the same amount of water and sunlight, and one grows differently than the other one. So this all is just dependent on these two things being different by nature. So again, you can pause the video, take a second to come up with your own example. And we're going to go to the next type of variability. Induced variability. This type of variability is in a marked contrast to natural. It occurs because we have assigned our population or sample to two or more treatment groups and then observe the variability between the groups. So it's kind of like forcing variability on one of them as opposed to the other. Here's my example. Two groups are treated on memory. One is allowed to sleep for 8 hours and one group is only allowed to sleep for 4 hours. The variability introduced in their ability to remember is induced. So I treated the two groups differently, so that causes perhaps different outcomes. Another example I have up here, two groups are given a drug to help reduce cholesterol and a placebo. So one group's given a drug, one group is given a placebo. If you don't know what a placebo is, it's basically not a drug. It has no effect whatsoever, but when people take what they think might be the drug, their body may like compensate for it because mentally they think they're taking the drug. But a placebo is basically like a sugar pill. It's not going to do anything to you. The variability in the subject's cholesterol level is induced. Okay, so create your own example for this one. And we're going to move on to D, sample variability. So sample variability is a type of variability that occurs when we take multiple samples from a population randomly. These samples will be different due to the randomness of the sampling process. So let's look at my example. Multiple samples of people are surveyed to determine their preference for a particular political candidate. Okay, so imagine like you went around the school and asked people what their favorite candidate was. The difference is in the proportion of people who like the candidate between the groups is due to sample variability. So it's just basically like sampling. Okay, and we just talked about sample variability. So then underneath it says, remember, through all of our work in this unit, we are really trying to explain the variability of data within either a population or a sample, and then using this to determine the variability if the variability can be attributed to one of the factors above to the exclusion of the others. Okay, so in plain words, the difference between population and sample is population is like everyone, whereas sample is like we're randomly choosing different people. So a sample is going to be a smaller selection than the whole population. So through what we learn in this unit, we're going to try to determine if any of these variability, different types of variability are coming up. Okay. There are many different situations in which we collect data. They have important differences, and all of them depend on randomization in one way or another. So exercise 2. The 3 major types of ways to collect data are going to be described. And I'm going to again show you examples, show you my own examples, but then I want you to come up with your own examples. So first example, surveys. Collections of data from a population where variability is not induced by treatments, but by the sample itself. So the variability is going to come from like the people that you choose. So the randomness in like the sample size or the sample who's in the sample. So here's an example. A marketing company wants to see which major soda is preferred in the general population. So they take a random sample of the population. They want a random sample of people, or they may end up with a sample that is not representative of the population. So they need it to be random, because if it's not random, you know, if you want, like here's an example. If the sample people in a natural grocery store, they'll be more likely to introduce bias in the sample because those people shopping at the store don't represent the population as a whole. So if you are trying to get a sample of people to see who drinks soda or not, and you go to people standing in line in a soda machine, that's not a good random sampling because those people are obviously waiting in line to buy soda. So you want it to be totally impartial to what the survey is about. So the people that you pick should be totally random. Okay. Here's another type, observational studies. So remember, these are all different ways to collect data. Collections of data from a population where assignment of individuals from the population into treatment groups is not under the control of those performing the study. So here's my example. A health organization might want to explore whether a person's state of residency has a relationship to their income level. So state of residency meaning where they live, what state they live in. A person, therefore, is assigned to a treatment group not by the organization, but simply by where they live. Here, those conducting the study must be wary that they make their sample of people from each state random. If they do not, they may sample an unusually high or low income level sample from a particular state, which could bias their conclusions. So the observational study, it's like the person conducting it doesn't set up the actual, the way the data is collected. They kind of just like observe what's going on in the study. Okay, another one, C, experimental studies. In an experimental study, individuals are assigned randomly to treatment groups in order to determine the effect of the treatment on the variability of the data. In these cases, the assignment, although random, is under the control of those performing the study. So unlike observational studies, you do have control over the study. So here's my example, and again, remember, for all of these, you're making up your own example. Seeds are divided into 2 groups, one of which receives an organic fertilizer, and the other group receives a synthetic fertilizer. The studies then look at which group has the greatest growth rate. Randomization is very important in this case, because if the seeds are not assigned to the 2 groups randomly, then it could be that one group has a greater growth rate, not based on the fertilizer type, but based on how the scientists performing the study decided on assigning the seeds. Okay, so random sampling is critical for being able to minimize variability due to sampling bias. Random sampling can be done using a variety of different techniques. Simple random sampling can be accomplished using a random number table. Okay, so in the next one, here's where we're going to actually do a little bit of math. So a list of 10 people's heights in inches are shown below. So you see the person number, so it's just like person number 1, person number 2, person number 3. It's not a frequency table. It doesn't mean that one person has a height of 70 inches. It just means that's the first person that they measured. So part A says, randomly select 5 heights from the list. It says all this stuff, but really it's just saying randomly select 5 heights. So I selected these 5 heights, 68, 66, 63, 70, and 69. I randomly selected them. Now the second part asks me to calculate the sample mean to the nearest 10th and compare to the others in the class. What type of variability is being introduced through this process? Okay, so in order to find the mean is just the average, if you remember. I'm going to add all of them up, and I'm going to divide by how many there are. So I can see there are 1, 2, 3, 4, 5 pieces of data here, so I'm going to add all of these numbers up, and then I would divide by the number 5. Okay, so I get 67.2. Depending on the sample mean, meaning the sample average, could be fairly different. In this case, we are introducing sampling variability into the process. So we talked about those different types of variability, and we talked about what type of variability this specific exercise number 3 might have. Okay, so in the space provided, I want you guys to choose your own 5 numbers, and I want you to calculate the mean for those 5 numbers yourself. And when I mean choose your own 5 numbers, I mean from this specific table. Okay, guys, that's it. Just a lot of vocabulary, a lot of new vocabulary, and we're going to talk more about this on Monday.